Hello, grade 10s. Welcome back to the channel. In today's lesson, we're going to be looking at electrostatics and we are doing exam questions. So without any further ado, let's just get right down to the lesson. So here we are given question 10. It says the diagram below shows two small identical spheres, P and Q, on insulated stands. The charge on sphere P is -3 times 10 to the power of -6 coulombs, and the charge on sphere Q is unknown. So as you can see from the diagram, we are given the charge on P, but then the charge on Q, we are not given anything, nada. So 10.1 says, calculate the number of electrons in excess, right? Now you will remember from our lesson video that we said, whenever you have number of electrons in excess, this is where we got to use the formula N is equals to Q over E. So it appears in the back of your formula sheet on the back of the paper. So it's always there, N is equals to Q over E, where we know the E is always a constant, which is substituted as -1.6 times 10 to the power of -19. So okay, let's just get right down to the question. So 10.1, we have our formula N is equals to Q over the charge on the electron. So sometimes they write it as E or they write it as QE, right? So now we have that formula, but then we are given the charge, right? Q is for the charge, and then we are calculating for sphere P. So that is -3 times 10 to the power of -6, and then over -1.6 times 10 to the power of -19. So we are trying to calculate the number of electrons in excess there. So now if you punch this in your calculator, this gives you 1.875 times 10 to the power of 13, right? But then remember, what are we calculating? We're calculating the number of electrons. So we need to come here and say electrons. So remember, there is no SI unit for the number of electrons. You just add the word electrons, right? Then you would have your 3 marks. Remember, I always say that with the 3 mark question is always a matter of having to choose the correct formula, substitute into that formula and get the correct answer. So there you go. You have your solutions like that. Now, the two spheres are brought into contact and are then returned to their original position. Each sphere now carries a charge of -1 times 10 to the power of -6 coulombs, right? Now 10.2 says calculate the original charge on sphere Q before the spheres were brought into contact. Now you will remember that whenever they speak about spheres being brought into contact and then separated, we said this is where now we apply the principle of conservation of charge, where we say when they are brought together there will be a sharing of electrons, but then the net charges will remain constant, right? So there will be no loss of charges during that physical contact. So we know the formula to calculate having to use the principle of conservation of charge is this one, right? So you will remember that for that one we use Q nu. We use Q nu is equals to Q1 plus Q2 over 2. But then with this question you will realize that we are already given the Q nu, right? Because here they said each sphere now carries a charge of -1 times 10 to the power of -6. Remember, we said when the spheres are brought together, they will then end up having the same charge, the same magnitude of charge, which will also have the same type of charge. So if they come out as a negative, they both are negative, and then if they come out as positive, they both will be positively charged. So now because there's that sharing of electrons, now they come as -1 times 10 to the power of -6, right? So that means sphere P, Q finally for sphere P is -1 times 10 to the power of -6, And then also the Q finally for sphere Q is also -1 times 10 to the power of -6. Remember, each sphere now carries a charge of that. So they have the same magnitude of charges. But now we are trying to calculate for sphere Q before they were brought together. So this is how we're going to do it. So we have Q nu. Remember here the Q nu is that negative, -1, -1 times 10 to the power of -6. But then the Q1, this is before it came into contact. So it was -3 times 10 to the power of -6. But what about sphere Q? Before it came into contact, we don't know. So we're just going to write it as Q2 like that. Then we say over 2. Now we know we have a fraction on the right hand side. So we might just as well make this one a fraction by saying over 1. Now at this point, we know mathematically we have to cross multiply here, right? So if you say -1 times 10 to the power of -6 multiplied by 2, that will give you -2 times 10 to the power of -6, right? Now having to cross multiply 1 and the expression here, then the expression will remain the same like that. So we have -3 times 10 to the power of -6 plus Q2. Now at this point, to calculate Q2, we need to isolate Q2. That means Q2 needs to be alone there. So what are we supposed to do? We are supposed to take this -3 and transpose it to the left hand side. So now let's do it. So we have -2 times 10 to the power of -6. Now transposing that, we have plus, because it changes the sign, then 3 times 10 to the power of -6, then is equals to Q2. Now having to add this 2 in your calculator, now you have it's I believe it's 1 times 10 to the power of -6. Then because this is a charge is always given in coulombs, right? The SI unit for charge is coulombs. So that becomes your Q2, which is the charge for sphere Q. So now sphere Q has a charge of 1 times 10 to the power of -6 coulombs, right? And that's how you could have tackled that one. Nice. Now, let's see 10.3. It says were electrons transferred from P to Q or from Q to P during contact. So now, having to look at this, let's now check. We have calculated sphere Q initially, and then we found that it's +1 times 10 to the power of -6 coulombs. Now we know, applying our principle of conservation of charge, we know that when it comes to sharing of electrons will always move from the sphere that is an excess of electrons to the one that is a deficiency of electrons. So now we can see that P is more negative, right? As we can see, that's -3 times 10 to the power of -6 coulombs, which shows you that it is negatively charged and has more electrons. But then Q, you can see that's 1 times 10 to the power of -6 coulombs, which shows you that it is positively charged, meaning that it has a deficiency of electrons and more protons, right? So now if electrons have to move, they will move from P all the way to Q, because remember, P has an excess of electrons and then Q has a deficiency of electrons. So the correct answer to 10.3, we say it's from P to Q, right? Awesome. Now let's look at another question. They say two identical insulated spheres, X and Y, suspended by threads from a ceiling, are held at a small distance apart as shown in the diagram below. Now, sphere X carries a charge of +4 times 10 to the power of -18, while sphere Y has an excess of 30 electrons. Now they say calculate the magnitude of the charge on sphere Y, right? So now if we can read on sphere Y, they told us about excess electrons, right? So we know whenever we see anything that has to do with excess electrons, we know the right formula for that one is N is equals to Q over E, right? As long as we see the keyword excess of electrons, the keyword excess of electrons, right? Then let's go to that one. Remember, here we are not supposed to calculate the number of excess electrons because we are already given, but now we are looking for the charge Q, right? So remember, with that formula, they can either ask you to calculate the number of excess electrons or the charge when they've given you the number of excess electrons. So in this case, we are given the number of excess electrons that's 30, and then it's equals to Q. But then we know the E is the charge on the electron, which is always negative 1.6 times 10 to the power of negative 19. Now at this point, we know what to do. This one we can say over 1, and then at this point we have to cross multiply. So if you say 30 times negative 1.6 times 10 to the power of negative 19, then do that in your calculator. So if you multiply the two, it gives you negative 4.8 times 10 to the power of negative 18. Then it has to be coulombs. Remember, it's charge. So that's coulombs. So that's sphere Y. Sphere Y has a charge of negative 4.8 times 10 to the power of negative 18 coulombs. And that's how you have your answer. Awesome. Then the spheres are now released and they move towards each other. So we can see the keywords there. They now move towards each other. So we know when they move towards each other, that's a point whereby they will collide, right? Now, 10.2, it says give a reason why sphere X and Y move towards each other. So now, why do they move towards each other? When you go back to our content lesson, our the video that I posted, if you haven't seen it yet on electrostatic, check that video, and then I've already explained everything to do with electrostatic. Now you will understand that we said if the charges are not the same, if we have unlike charges, we will always have attraction. So with unlike charges, we will always have attraction, right? But then if the charges are the same, so for like charges, let's say we have a positive and a positive, they will always repel. If also we have a negative and a negative, they will repel. So why are they moving towards each other? Now remember, when we speak of moving towards each other, we speak of attraction, right? So they move towards each other because they have unlike charges, right? So unlike charges, so we say unlike charges attract. That's why they move towards each other. Now the spheres are allowed to touch each other. After touching, they move away from each other. Now you will realize after they touch, remember after they touch, they now have the same magnitude of charge, and also they have the same sign, right? So they will have like charges, right? So same magnitude and also like charges. That's why after touching, they will then move away from each other, meaning they will then repel, right? So always after that moment of touching and sharing electrons, afterwards they move away from each other because now they have the same magnitude of charge, and then the charges are also the same, that like charges, right? So 10.3 says state the principle of conservation of charge in words, right? So you will also remember that we stated that one, the principle of conservation of charge. Now let's go. What does it say? It says the principle of conservation of charge states that the net charge in an isolated system is conserved. That is to say, during that physical contact, there is no loss of charges, right? So we say the net charge in an isolated system is conserved during any physical contact, right? Then 10.4 says calculate the charge on each sphere after they have separated. What are they looking for here now? Then the charge on each sphere. Now we know the charge on each sphere is the new charge, so they're looking for Q new. Remember, always the hint here is whenever they ask you to define the principle of conservation of charge, then the question that follows afterward, when it says calculate, then you have to apply that formula for Q new, because remember that formula for Q new is the one for the principle of conservation of charge, right? So always note the trend in the questions. Then we have Q new. We have Q new is equals to Q1 plus Q2 over 2, right? So now let's look at our charges. What do we have for Q1? So we have that positive 4 times 10 to the power of negative 18. Remember, we are given, so 4 times 10 to the power of negative 18. But remember, we just calculated Q2, which was for sphere Y, right? So what is that? What do we have for that one? We calculated it to be negative 4 point. So that's negative 4.8 times 10 to the power of negative 18, right? So let me write that nicely. So we have it here. So we have 4 times 10 to the power of negative 18 plus negative 4.8 times 10 to the power of negative 18. But because we are comparing two charges, so we have over 2, then punching that in your calculator, we now have negative 4 times 10 to the power of negative 19 coulombs. So that becomes the new charge on each sphere. Awesome. Then let's look at the last one. It says two small identical spheres A and B are suspended on long silk threads as shown in the sketch below. The spheres carry charges of positive 3 times 10 to the power of negative 6 coulombs and negative 2 times 10 to the power of negative 6 coulombs respectively. Now 10.1 says which sphere has an excess of electrons. Now you will remember that we said obviously the ones that are negative, more negative than the ones that have an excess of electrons. So we can see this one is negatively charged as a result of the electrons being greater than the protons, right? And then this one is positively charged as a result of the electrons being less than the protons, right? So now we know that if it is positively charged, we have a deficiency of electrons, and then if it is negatively charged, we have an excess of electrons. So the correct answer to 10.1 is definitely B, right? Then 10.2 says the two spheres are allowed to touch. Then the two spheres are allowed to touch. Will the electrons be transferred from A to B or B to A? Now again here, we know that electrons are always transferred from the one with an excess of electrons to the one with a deficiency. We've already said that this one has an excess, so that means obviously this one is a deficiency, right? So that means the electrons will move from B to A, right? From B to A. So awesome. Then 10.3, the spheres are now separated. Calculate the new charge. So with this one, you can see it was straightforward. Calculate the new charge on sphere B. Now we know with the new charge will be the same for sphere A as it will be for sphere B, right? Then to calculate the new charge, we know the formula. The formula is Q nu. Q nu is equals to Q1 plus Q2 over 2. Then what do we have as our Q nu? As our Q1, we have that 3 times 10 to the power of negative 6. Then plus, we have negative 2 times 10 to the power of negative 6. Then over 2, right? So if you punch all that in your calculator, what do you have? We have 5 times 10 to the power of negative 7, right? Then coulombs. So punching that in your calculator, you have that, and don't forget the SI unit. So that's the new charge on sphere B, right? That's the new charge on sphere B, and it will also be the same for sphere A. Now 10.4 says calculate the number of electrons transferred during contact, right? So now we have here number of electrons transferred. Then this one is not to be confused with number of excess electrons. So when we have number of electrons transferred, this is now where we have N. This is now where we use the formula N is equals to change in Q over E. Now the change in Q, what is the change in Q? This is where you will say Q finally minus Q initial. Then it's over that E, right? So now let's check this one. How do we apply this one? So for 10.4, we have, because they said the keyword there is transferred, electrons transferred. So whenever we have a transfer of electrons, we need to compare, we need to check the difference between the final charge and the initial charge, right? So if we are looking in terms of sphere B, right, with this one you can choose any. You can choose to calculate using sphere A, or you can choose to calculate using sphere B, right? So now let's say we are using sphere B, right? If we are using sphere B, let's break down this formula. This is QF minus QI over E. The final charge for B, we have calculated it to be 5 times 10 to the power of negative 7, right? Then subtract that from sphere B. Sphere B had a charge of negative, so you need to put that minus and that negative 2 times 10 to the power of negative 6. So you need to be very careful with the signs here. We have the minus from the formula and then the negative, which indicates the charge, right? Now if we do this, we can see that negative and negative will be a positive. So adding the two, there will be a positive answer in the numerator. Now that will determine the E that we are supposed to have here. If the numerator here is positive, then that means even our charge on the electron will now have to be positive. So here we're going to have 1.6 times 10 to the power of negative 19. We know from the formula it comes out as a negative, but for the sake of, remember your number, the number here of electrons cannot come out as a negative. So that's why we are doing that. We are changing this one to be a positive so that when we calculate number, it doesn't come out as a negative. Now if you punch that in your calculator, if you punch all that in your calculator, you have 1.56 times 10 to the power of 13. And then remember, you need to say, so to the power of 13. Then remember, you need to say electrons, right? Electrons. Right. Let's see if we want to get the same answer if we are calculating now using a sphere A, right? Remember here we were using sphere B, right? So this is sphere B, and then we got 1.56 times 10 to the power of 13 electrons. Now let's use sphere A. Again, the same formula, N is equals to change in Q over E, right? So change in Q, we have QF minus QI, but we know the QF is the same. The new charge is the same for both spheres, right? Since they would have came into contact and then separated. So this is 5 times 10 to the power of negative 7 minus, but the Q initially for sphere A is 3 times 10 to the power of negative 6, right? Then that over, now we know if we have to subtract this one, our answer will come out as a negative. So the first thing that you want to do before you substitute your E, just check here. Press this in your calculator and check if you're going to have a negative answer or positive answer from adding those, right? So from adding this, we will get a negative answer because here we are taking a smaller number and we are separating it by a bigger number. I know it can be pretty confusing since you have 5 here and then you are thinking, how can it be a smaller number? Remember, we are looking at a negative 7 here. So this negative 7 makes it a smaller number than this one that is a negative 6. So that will give you a positive. Remember, if you are taking a smaller number and you are subtracting a bigger number from it, the result will be a negative. So here we need to divide now by negative 1.6 times 10 to the power of negative 19. Why? Because that negative from the numerator and the negative from the denominator will now make our n a positive, right? So that's the manipulation that you have to know. Then having to put all this in your calculator, if you punch all that in your calculator, what do you have? You will see that you will also get the same answer, which is 1.56 times 10 to the power of 13 and then electrons, right? So that's the number of electrons that are transferred during that physical contact. So yeah, with all that being said, that's it for the lesson. Keep on practicing, guys. All the best. Ra.